Hello everyone, I'm so excited to be here today to share our work on OmniLottie. Here is a quick look at the amazing animation OmniLottie can generate. Before diving into the technical details, why did we focus on the Lottie format? Essentially, Lottie is a tiny JSON file. It's lightweight, making it load extremely fast. In production, it bridges the gap between designers and developers by exporting complex After Effects animation directly into native code. Moreover, it runs perfectly across WebOS and Android because it's a vector format. It scales infinitely without losing any quality. Industry giants like Google, Apple rely on it every day. Automating Lottie generation solves a massive real-world bottleneck in the industry. The traditional design process is tough. Designers have to rely on complex software like After Effects, which takes days or weeks and make even tiny edits a nightmare. Our OmniLottie takes that and generates a full usable Lottie JSON file end-to-end in just minutes. Existing optimization methods like any clip paths suffer from severe geometry distortion and only output MP4 videos, not true vector animations. On the other hand, if you ask general models like Parameterized Report 1 Pro to generate Lottie JSON directly, they fail often. Even a missing bracket breaks the whole animation, leading to blank screens. To solve this, we completely rebuild how the underlying data is represented. If we force a model to write deep, nasty JSON, it easily gets confused. Our core contribution is the Lottie tokenizer. We flatten the deep JSON tree into a 1D sequence using a custom vocabulary. We map the complex code into several token types, commands, spatial, temporal, and so on. Built on visual language model, OmniLottie aligns this tokenizer with standard multimodal inputs. The model accurately predicts the next Lottie token, which is then decoded to render through its animation. Here's how the core workflow happens. Giving a prompt, the model generates Lottie tokens. Finally, the code and the timeline meet in the render engine to produce the final animation. Why build a custom tokenizer? Raw JSON is huge and causes context window limits to explode. We set up a 3-step pipeline to clean it up. First, deformatting. We remove useless brackets and indents, cutting tokens by 34%. Second, instruction abstraction. We map deep properties into complex control commands, cutting length by another 50%. Finally, numeral quantization. We precisely quantize continuous, spatial, and temporal flows. In total, we achieve an 81% token compression rate. This cuts out all the noise while keeping the animation completely flexible, making autoregressive prediction much easier. Clean, standardized Lottie datasets just didn't exist before this. Crowd data is massive, expensive, and full of fake Lotties. So we built OmniLottie 2 million, the industry's first million-scale multimodal Lottie datasets. We built out batch samples, normalized spatial coordinates and frame rates, and then rendered them to extract visual features. Finally, we use advanced models to write rich captions. We also noticed a lack of proper evaluation measures, so we created OmniLottie Bench. It features 900 test cases for text to Lottie, text image to Lottie, and video to Lottie. To keep it fair, we split it into a real subset made by human designers and the synthetic subsets generated by AI models to prevent future data contamination. As the table shows, OmniLottie hits an over 90% success rate, crushing previous methods in visual quality, multimodal alignment, and motion accuracy. Looking at our qualitative results, you will see a lot of red crosses. General models like DeepSeek and Crash break frequently when asked to generate Lottie because they output invalid JSON structures. For text image Lottie, general models fail at a high rate. Our final task is video to Lottie. Taking a video into a vector format again, general models like GPT-5 and Parameterized Report 1 Pro mostly fail, but OmniLottie outputs accurate vector reconstruction. Thanks for your listening.